So moving on to a system of quadratic equations, the method doesn't change. We still need to isolate y in one of the equations, which then allows us to substitute it into the other equation. Looking at these equations, the easier equation to isolate y in is the first one, because in the second one, if we try to isolate y by moving it to the right side, we'll have to take a second step and subtract 4. In the first equation, if we move y to the right side, then we have y isolated automatically. So if we do that, we end up with, let's try that again, 3x squared minus x minus 2 equals y. That tells us literally that every time we see a y in the next equation, we can just put in 3x squared minus x minus 2, and it is the same thing. So when we do that, second equation, we have 6x squared plus 4x minus y minus all of y. And that equals 4. Why am I putting brackets around what I've substituted in? Because we're subtracting y, we're subtracting the whole of it, every piece of it, which is going to impact our next step. How does that impact the next step? Well, we need to distribute the negative in, which in reality is just going to switch the signs on all the terms. We have some like terms we can combine. 6x squared minus 3x squared would give us 3x squared. 4x plus x would be 5x. 2 has nothing like on the left side. 4 has nothing like on the right side. As with most quadratic equations, we want to get a 0 on one side, so I'll subtract 4 from both sides. And we're left with a quadratic equation here. Factoring may not be the best method to go with here because we do have 3x squared. That significantly ups the difficulty level of factoring, so we'll look at something else. Completing the square, also somewhat more difficult with a 3x squared. So I'm going to go with quadratic formula. As usual, it is a foolproof method. It's never going to lead you wrong. It might be a little longer than some of the other ones, but it will always get you to the right answer. So we need to define a, b, and c. A is 3, b is 5, c is negative 2. I'm going to flip to the next slide to start doing that. As we all know the quadratic formula by now, x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Substitute in what we know. B was 5, so we have negative 5. We have 5 squared minus 4. A was 3. C was negative 2. Divided by 2a, 2 times 3. Start working out the math. 5 squared is 25. Negative 4 times 3 times negative 2 gives us plus 24. 2 times 3 gives us 6. We end up with 49 under the root square root of 49 is 7. And from here we need to split off to find both values of x. On the left, top will give us 2. 2 over 6 reduces to 1/3, which, if we wanted to go to a decimal, say at least 2 decimal places, 0.33. No stopping you from going to more decimal places, but minimum of 2 here. On the right, we have -5 minus 7 on top, which gives us -12, and -12 over 6 is -2. So we have 2 values of x, which we then need to substitute into one of the equations in order to find the corresponding values of y. So if we go with x equals 0.33, I'm going to take that manipulated version of the first equation, which is right here. As it already has y isolated, it's easy enough just for us to substitute in x and do the calculations. So we have that 3x squared minus x minus 2 equals y. Substitute in x is 0.33 here. Go ahead and do the calculations. We need to do 0.33 squared, which is 0.1089. Multiply that by 3. We get 0.3267 minus 0.33 minus 2. That equals y. If we calculate that out, we get negative 2.0033. If we're going to go to 2 decimal places, negative 2.00. And we could just call it, if we're going to round it, that y is -2. So this point of intersection would be at 0.33 and -2. Our second x value was at -2. Substitute into the equation. We have 3 x is -2 squared minus -2. Yes, there are 2 negatives there. One from the equation, one from the 2. Do the math. -2 squared is 4. Multiplied by 3 is 12. Subtract -2 is actually +2. And -2 there. Work that out, and we get that y is 12. So our final point of intersection is at -2, 12.